Hey everyone, let's go ahead and get started with the Langchain projects. Langchain has recently launched its version 1 library, and we are going to see here that how you can use these Langchain APIs and the Langchain Python package to make your semantic search project. We will be making here so many projects. So we'll start with the semantic search, and this is the fundamental of RAG. So basically here I'll be showing you how you can ingest your document into the vector database. All right, let's go ahead and see the presentation. First of all, I have prepared this presentation in HTML. To see your HTML in VS Code, you need to search here HTML preview extension, and this is the extension which I have installed here. Once you do that, then you can see this HTML file here. All right, so we are seeing our HTML file here. Let's go ahead and see what we are going to do in this particular lesson. So we'll start with the document loading, and thereafter we will start with text splitting, and then we will see that how you can do the document embedding, and thereafter how you can store your document into the vector store, and thereafter I'll be showing you how you can retrieve those documents. So this whole thing what you see here, this is the fundamental of the RAG. This project is not like a traditional RAG, but this is like a foundational project. I'll be showing you how you can make your foundation is strong for the RAG. Then finally, here is overall architecture. So this is something which we will be implementing here. We will be taking our PDF document, and then we will be chunking those PDF document and pages into the text chunks. And then we will be using the embeddings to convert our text data into the vector data. And thereafter, we will be doing retrieval. So basically, we will be getting the search result from the vector DB. And then those results can be passed to the LM, which we will not do in this particular lesson, but later on in this particular series where we are going to cover Langchain projects, we will definitely do that. And the project code file is available at my GitHub. You need to come here at GitHub. All right, Lakshmi made it here, github.com, Lakshmi made it. And there you can find out this particular project, Langchain P1 project. All right, so I will update all of my code and the notebook and the presentation here itself. You can download this project and then you can get started with this. Perfect. So enough talking. Let's go ahead and get started with this. So the first of all, what you have to do here, you have to install the Langchain, LangGraph, Langchain Chroma, Langchain Ollama, and the Langchain community and the PyPDF. So the PyPDF will be used to read the PDF document. Once you have done all of these things, thereafter we are ready to import our necessary Python package in your notebook. One more thing I should tell you here that you need to use here Python 3.11 or lesser than Python 3.12. Why it is important? Because the Chroma does not support Python 3.12 currently. So actually the Chroma is having issue with the Python 3.12 and the 13. So I recommend you to go with the Python 3.11. Otherwise, you might be having an issue with your Chroma. Let's go ahead and save some space here. So I'm just going to do like this. And also I can see this presentation here so that I can be referring this presentation while I'll be doing the coding here. So first of all, I import here necessary libraries, Python package, like I need to import Langchain Chroma, Langchain Ollama, and then from the Langchain community, I import PyPDFLoader. So there are so many type of the document loader available in the Langchain. So one of those are here the PyPDFLoader, and then we are also going to use here text splitter. So the text splitter works like splitting your whole document into the smaller chunks so that you can embed those text data into the vector space. That's all you have to do here. Let's go ahead and run this. Once you execute this, it is going to connect with your Python environment and then it is going to execute. All right, so we have imported all the necessary Python package here. Let's go ahead and see how you can download online PDF and then how you can load that using the PyPDFLoader. So first of all, we need to find out a PDF. So here is an online PDF document, which is 174 page document. a survey on large language model with some insights on their capabilities and the limitation. All right, so this is the research paper kind of things and a very large, the LLM research paper here where they have done the survey on large language model. So this whole document we are going to download and then we are going to chunk it and thereafter we are going to store it into our vector database. So I get this whole, the whole link from here and thereafter what I do here, so I'm just going to use that whole thing from there. So I just bring my code where we are going to load this particular PDF and we are going to use here a PyPDFLoader from this given URL and then it is going to load that. Once it loads that, thereafter this whole document what we had seen there, that is going to be converted into a LangChain document. Let's go ahead and run this and then see what happens now. So it is going to take a while to download that and then it is going to convert that into the text data. If you check your documents now here, you will see here this is converted into the LangChain document. All right. And this LangChain document is going to have here a metadata. And along with that, it is also going to have the page content. All right. Do you see here this page content? So this is the two important thing available with the LangChain's document object. You can see here a single document event. With this, you can see the single document and thereafter you can check all the keys available with this particular document. Seems like the keys are not available. But if you check that, so you have here a metadata and apart from that, you have the page content. All right, that's all you have here. All right. And other than that, if you check your document here, you just right click. In fact, doesn't seems like we have a document there. But these documents which we have here, these documents also have internally ID in the LangChain. So we can also define the ID in the LangChain documents as well. All right, once you have loaded your document, let's go ahead and see how many pages are loaded. So what I do here, basically, I'm just going to run this and it says that 174 pages from the PDF document is loaded. That's when each document are representing here a single PDF. Each document is representing here a single PDF page from this particular document. All right. Thereafter, we are going to actually print some sample content from our first document here, and then I'll show you how it overall look like. So as you see here, if I print the sample doc, that's the first document here. So the first of all, now I see the page content here. All right, how many characters are there? 2140 character. And the metadata is like this. The creator latex, the creation date is like that. The author is there, keyword, and all these metadata is available. And with that, there you also have here a source as well. All right, so this is from we download this particular PDF. All right, and the total pages are 174 and so on. Then you have here a content preview. It starts with a survey on large language model with some insight on their capabilities and limitation. And then you have here all the author name and etc. If you compare here with this, you will see here all these document contents are coming there. So this says that we are successfully able to read that online document here. All right, perfect. Now the next step here in this our document, we have a text splitting. Once you have this whole document, if you notice there in your sample doc here, so this page content is quite large. The total number of the character is here 2140 character, which is quite large. All right. So now we need to break down these content into the smaller chunks. So to break it into a smaller chunks, what we are going to do here, we are going to call our recursive text splitter. So this one is provided by the LangChain itself, which works by dividing a larger chunk into the smaller chunks, like let's say this one and then this one and this one and so on. All right, so what I do here, I'm just going to bring my recursive character text splitter here. So the first of all, I come here, thereafter I paste here that we are going to configure our text splitter here. So with this, what we do here, we write our recursive character text splitter. The chunk size we are going to use here 1024 and thereafter the 10% overlap we are going to use, which is going to be the 100. All right. And the length function we are going to use as a length and then add start index. So basically it is going to also add the index for each chunk, that from which particular index this chunk starts. So with this, we get our text splitter. Once you get your text splitter, then we can pass our document into this text splitter. Then it will split those into the multiple chunks basically. Now what I do here, I just bring my additional code here and then I'm just going to paste that so that you can understand what is happening here. So what do you see? Now this is actually splitting the document into the multiple chunks. Now you have got your chunks. Now here it says that this is the total length of the document. And here it says that this is the total length of the chunks. All right. Let's go ahead and run this and then see this overall analysis. So here it says that the chunk size is 4096. Seems like that is wrong actually. The chunk size is 201024 and the overlap is 100. Basically, I have decided that. All right. So the chunk size is this one as specified, and this is the overlap character, recursive character split. So it says that out of 174 pages, now we have got 593 chunks. And this is huge actually. All right. Perfect. Thereafter, we see here that what is the average chunk size? 858 characters on average chunks. And this is the largest chunk and this is the smallest chunk. All right. Now you have got your chunk. Let's go ahead and check your chunks here. So we can check our chunks here. Now you will notice here that all these individual documents in this chunk is also a document instance. And all these documents are having the same metadata here as you see. I mean the same keys as we had in the original document, metadata, and along with that, we also have all these things. Then you will see here we also have a page content as well. All right. So all these things we have right now. Let's go ahead and see how you can create the embedding. So to create the embedding, as you see here, we are going to use here Ollama embedding. I already have my Ollama, which is running here. So this Ollama is installed and running. And in Ollama, we are going to use here nomic embed text method, this one particularly. Nomic embed text embedding model. So if you don't have that particular model, then you can just simply write here Ollama pull that particular model name, then that is going to be pulled there in your local computer. All right, perfect. Let's go ahead and get our embedding function first of all. So I'm just going to get my embedding function first of all. So this is how I get my embedding function. Embedding equal to the Ollama embedding. And in that, I need to pass the model which I need to use for my embedding and then the base URL. With this, I just simply run this. Now we have got our embedding. Once you get your embedding, now you can use your embedding to get the query embedding. So basically you can write here like this embeddings dot embed query, and like that you can do. You will notice that you will get here the vector representation. So first 5 vector representation we have got. If you print this, then you can get this whole vector representation. You can also get the length of your vector space, and it says that some 768. All right, so this is the vector space. Basically, whatever query you pass in the embedding function, that is going to convert into 768 dimensions. All right, once you have your embedding method, thereafter we need our vector store. So for the vector store, we are going to use a chroma. We have already imported our chroma here. As you see from the Langchain chroma, we have imported the chroma. If you press the control and click on this, you will see that whole document detail about the chroma. All right, so these are the input parameter which it takes, like it takes the collection and the embedding function. These are the most important thing, and rest of the things are optional and it can assume by default the other things. And these are the document type which it accept here, that like this document where you have a page content and the metadata. Even if you don't have the metadata, it can accept the document without the metadata. And ID is generated internally. All right, if you pass ID externally, it is fine. Otherwise, it generates these IDs automatically behind the scene. And these are the methods available with your Chroma vector store, like delete document, update document, add document, instantiate, search with filter, search with score, and so many things. All right, perfect. Let's go ahead and create our vector store and then add our document. So what I do here that I'm going to create a vector store and then I add document in our vector store. So I come here simply and thereafter I'm going to create our vector store. I'm going to give collection name as a PDF collection and the persistent directory is going to be the ChromaDB. All right. So the ChromaDB is here created, which I did previously. Let me just delete this. All right. So this ChromaDB will be created here. And inside that, there would be a collection name that is the PDF collection. All right. And thereafter, we are going to add all the chunks here. Remember, we are adding here chunks. So the chunks are after, the chunks are coming after we split these document. All right. So we got our chunk here. Then vector store will automatically get updated and this will say that these many chunks got added into the vector store. Let's go ahead and run this and then see what happened here. All right. So this is the initial the print statement, like we are explaining here that what we are doing here. And then it says that 593 document chunks to the vector store got added. And if you check here, 593 chunks we had initially, that means all the chunks got added in our vector space. And we can see here our ChromaDB is there and this is the collection here. You see here this collection got converted into the hexadecimal digit. This is the hash function basically. All right, so your collection name got converted into the hash function. Thereafter, once you have your vector store, now it is time to query with your vector store. Now the question is how you can query with the vector store. As we had seen previously with our Chroma, there are so many methods available with the Chroma, which we can use to, which actually we can use here. Like you can use, let me just see here, search. You can use search with filter like this. Vector store.similarity search, vector store.similarity search, vector store.similarity search with the score. So these things we can do with this. Let's go ahead and do. First of all, we are going to do here vector store.similarity search for one of the simplest query which we can have here. That is, what is the main methods available for RAG in our document. So this is the document. Let's go ahead and search. Do we have RAG methods? Seems like yes, not like that. Let me just see here with the space. Yes, we have here RAG frameworks and these things. Now we should be getting here a couple of chunks related to RAG. Let's go ahead and check that if we get the chunks. Okay, so I'm gonna see here 5 similarity search, 5 scores basically, the top 5 one. Let's go ahead and run this and then see if we get into the result. So it is running here the basic similarity search. Let's go ahead and check the result here. So now I check the result. I have got the 5 document. In these document, if you check here, the page contents here we have got. So this is the first page content. It says that some benchmarks such as the squared, etc. Specified, task, widely used, assessment, RAG faces several, etc. Now I can see that yes, RAG was there, RAG is here, RAG is here. So basically seems like, yes, it has got the content relevant to the RAG. So all these top 5 content it has extracted, which are completely relevant to the RAG. So this is how you can query your vector store. Let's go ahead and print these, the extracted document in the formatted way so that we can do analysis in more better way. So I'm just running this and then I'm going to delete this. So here you see, this was our query and these are the result here. Let's go ahead and see it into the text editor. So here we have a basic similarity search. Query was here. What is the main method available for RAG? Retrieve 5 most similar chunks. So here you have a result one. The content is this one and which have things related to the RAG and the page source is here page number 122. There is the another result which has RAG related things at page 117, 118, 122 and 119. So the one thing I notice here that all these RAG related things are mostly between page number 115 to 125. Seems like that is the the block of block of the research paper in the document where they have explained about the RAG system. All right. Now let's go ahead and see how you can search with the similarity score. As you see here in the ChromaDB, let me just again click here, this one, so that I can see here. So in this, you will notice we have a multiple option, similarity search, and then similarity search with score. In the similarity search, we also have here a filter. Later on, I'll show you how you can work with the filter. But you also have a similarity search with the score. Let's go ahead and check how you can do this similarity search with the score as well. So you need to come here. Thereafter, you need to find out here vector store dot similarity search with the score. And here we are passing a query. This time we are fetching here only top two document, and thereafter we are printing these fetched document for the debugging purpose. Let's go ahead and print those top two document. So here it says, and thereafter it must be showing us the score as well. Let's go ahead and check the score. Where is this one? Yeah, here is the score. So this one we have, and thereafter we also have here the another document. All right, so this is also coming with the score. All right. Let's go ahead and try to find out the top 5 document and then see what output we get here. So for the top 5 document, it is searching. It has here the first document, then the second document, the third one, then the fourth one, and then so on. As we scroll it down, now we find out here the fifth one. All right, so all these documents, as you see here, these are related to the RAG. If you go in the detail of these documents, you will find out that all of these documents have things related to RAG only. So this is how you can search with the similarity score as well. Let's go ahead and see how you can apply the filtering. As we saw here in the document where you have a vector store.py, there, this is the way how you can apply the filter. Let's go ahead and see in your document here how you can apply this filtering. All right. So here you have most of the things are exactly going to be as it is. The only thing we are going to apply here, the filtering. Okay. So before we apply filter, let's go ahead and see what metadata we have. And based on that metadata, we can decide that what type of filtering we want to apply here. So you see here, we have these kind of the metadata, like we have a producer, we have a creator, we have these author, a keyword, all these are the empty. Thereafter, we have here, the total pages and the page number here and the page label here. All right, and the start index. Let's go ahead and apply our filtering for a specific page number basically. All right, since page numbers are there, so we can apply with the specific page number. There we have a page and here is the target page. So basically I want to use here first available page. All right, and that is going to be selected by the page number here. Let's go ahead and run this and then see. So we are going to filter based on the page, and this is top two result for the page 0. So we have here page 0 framework that integrate external system, etc., etc. And the another result we have here that is coming from the page 2 as well. All right. So this is how you can do. Let's go ahead and if we print here the top 10 document and then see how many documents we are gonna get. So the one thing you will notice here, we are not getting more than 3 pages. Why? Because anyway, in our page here, in our document, we do not have more than 3 chunks from the first page. That is why we are getting here only top 3 results. Irrespective, we are trying to get here top 10 result. So this is how you can apply the filtering, and this is how you can do a similarity search with the metadata filtering. Let's go ahead and see how you can do the multiple metadata filtering if you want to do. So let's say if you want to filter over the multiple metadata, that part you can also do here. So for the multiple metadata, this is the way how you write the filter method. All right. So this is your query like research finding, and top 2 we are gonna get here. We are gonna get the page which is greater than page 0 or equal to the page 0, or we can say that here 10. So it is going to get the page 10 or greater than 10, and thereafter it is going to the apply here a source. So basically it is going to say that it must be having some source. Let's go ahead and run this and then see what happened here. So I'm just going to run this. It is going to extract the data, and it has found these two documents here. So the first one is coming from the page 118 and the one is coming from the page 163. Let's go ahead. If you try it LTE, that is the less than or equal to, now we should be getting output from the page number 10 or lesser than 10. Now we are getting from page 4, and then this one is also coming from the page 4. So this is how you can do these complex metadata filtering. All right. Now let's go ahead and see how you can convert your vector store into the retriever. So retriever will be used in the Langchain codes later on, where we will be using our RAG system. So converting your vector store into retriever is a very good idea. Let's go ahead and check that how you can convert vector store into the retriever. So the process is very simple. You just need to write here vector store dot as retriever, and thereafter you need to provide the type of the search. So there are multiple type of search we have with the retriever, like you have a similarity search, we have a MMR search, and we also have a uh, similarity score threshold search. Let's go ahead and see how you can do with the similarity. So search type is a similarity. So basically this is going to use here cosine similarity for a given query. So this is how you get your retriever. Once you get your retriever, thereafter you can thereafter you can just fire your query on this particular retriever. Let's go ahead and do that for some particular some particular query. So the query I'm going to use here, what are the key contribution in this particular research paper? And then it is going to use the similarity retriever. Now the one thing you will notice, earlier we had with our vector store here, if you notice, we had a similarity search and similarity search with the score. But right now with the retriever, we are having here invoke method. All right. So you have a two method with the retriever. One is invoke method and another one is a invoke method. That is the asynchronous invoke method. And this is your final query which we had here. Let's go ahead and run this and then see how many document it has got here. So we had decided here 4 document. That is why it is getting the 4 relevant document for this particular query. Let's go ahead and see those document here. So I'm just gonna see those document. What are those document basically? So I just simply run this. It says that first of all, it is coming from the chunks here, contents here basically. So says that, okay, in the content which you have here, these are the key findings. So from this content, you can get that, okay, in this paper, these are the key findings or the contribution to this paper. And then they have some data here on the chunk 2. Seems like they have explained that what are the contributions here. All right. Now you can change your query here, this one, if you want to change. Let's say you want to make it final query that I say that what are the main LM model used for RAG. Let's go ahead and run this. Now we should be getting here a different output. All right. So now we are getting these output where it has all the LM things here. All right. If we go in the detail, then we should be getting some information about that. What are the LLMs are used for the RAG. All right. Now I hope that this particular, the go through, or you can say the crash course on the semantic search was helpful to you. And also I request you to please do like this video and subscribe this channel so that whenever I publish new videos, you can get the latest update. All right. Bye-bye. Take care.